All right, let's find this flux integral. The flux integral f dot ds is the same as f dot the unit normal. For the unit normal, let's look at this surface. It's described as z squared equals x squared plus y squared. That gives me the cone. Oriented downwards, so I want z negative, so let's move it this way. So we have 0 equals x squared plus y squared minus z squared. And then, so my unit normal would be the gradient, 2x, 2y, negative 2z. Make it into a unit vector. Square root of 4x squared plus 4y squared plus 4z squared. And pull a 4, square root it out, and that'll just give me x, y, negative z, all over the square root of x squared plus y squared plus z squared. But on our surface, x squared plus y squared equals z squared. So this will be the same as x, y, negative z, all over the square root of z squared plus z squared, or 2z squared. Change that later. No, I'll do it here. So x, y, negative z, all over square root of 2z squared. Let's do our dot product. Nice and simple. Well, 2/3 of it will be. So of course we got 0, 0. Those will cancel. Then this times negative z over square root of 2z squared. So we're going to get 2x to the 4th, y to the 4th, z squared, and then times negative z all over square root of 2z squared. And z is positive, right? We've got 0 less than or equal to z less than or equal to r. So this will come out as a z and cancel. So in the end, we're just going to have negative 2x squared, x to the 4th, y to the 4th, z squared over root 2. It might simplify, but let's leave it. It's going to go away anyway. ds is the square root of partial z partial x squared plus partial z partial y squared plus 1 dA. My surface is z equals x squared plus y squared to the 1/2. That's the rule right there for the cone, even though we rewrote it a couple times. But so this will just be x over the square root of x squared plus y squared. If you take this partial derivative, you'll get 1/2 x squared plus y squared to the negative 1/2, then times 2x. This gives me that. So we have to square this. Similarly for y, we'll get 1/2 to the negative 1/2 times 2y. It'll be y over square root of x squared plus y squared. And we'll square that, and then plus 1. So if we simplify, we'll get the square root of, get a common denominator, x squared plus y squared. And then plus 1 will be plus another x squared plus y squared, all over x squared plus y squared dA, and that'll end up just being root 2. So my integral f dot n ds, here's my f dot n, here's my ds. So it's going to be, we're down to, well, let's see. I'll do one more thing. So we have to integrate negative 2 x to the fourth, y to the fourth. So we're integrating this, and I can only have the two variables. Everywhere on the surface, what does z squared equal? X squared plus y squared. We divide by root 2. So that's f dot n. ds is root 2 dA. Those will cancel. Let's say d. Our d, we might know what it looks like because it's got a cone. We're going up to z equals r. The equation for the cone is z equals square root of x squared plus y squared. So if I put these equal, d is just a disk of radius r there. So in the end, we're going to do this in polar. We've got our downward unit normal. Notice for the unit normal, the z component of the unit normal, if I only look at the z part, it was a constant negative 1 over root 2. All right, you had a 45-degree angle downwards. So z is always the same direction. X and y changes on the unit normal anywhere on the surface, but z, the z component of the unit normal, is always the same. So in polar, goes 0 to 2 pi, 0 to r, negative 2 r cosine theta to the fourth, r sine theta to the fourth, r squared, then times r dr d theta. And we can actually write this as a product, so this will equal 0 to 2 pi cosine to the fourth sine to the fourth, and then this will be 0 to r. What do I've got? I've got the negative 2 somewhere. I'll keep it here, I guess. Negative 2 r to the 8, 10, 11. So that first integral, not easy. It's 3 over 64 pi. And this one is easy. So times negative 2 r to the 12th over 12 from 0 to r. So this will just be whatever it'll be. I guess that's a 6. No, that's a 6. Cancel that 2. So negative pi over 128 r to the 12th. So right, 6, 2, 128. So there's the answer for that one.